All right, so the last bit of 9.6, we're going to be solving right triangles. So what it means to solve a right triangle is to go ahead and find all unknown side lengths and angle measures. And as long as you know at least two of the sides, you can do this, or one side and then the measure of one acute angle, because again, this is always within a right triangle that we're talking about, okay? Now, if you're wondering, how do you do it when it's not right? We'll get there, okay? Don't worry. So we can use special Pythagorean theorem, special right triangle relationships, or trig ratios, depending on what's given. So let's try a couple. First of all, when we look here to find c, well, we could have done that a while ago. We have our Pythagorean theorem. So 2 squared plus 3 squared equals c squared. 4 plus 9 equals c squared. So c is equal to the square root of 13. So I filled in all of my sides. So we're doing great there. Now my angle measures, we obviously have one of them. It's the right angle. Now what I can use, because this is not a special right triangle, meaning it's not a 45, 45, 90 or 30, 60, 90, what I can do instead is one of my inverse trig functions. So let's take it from, how about angle A? Okay, so from angle A, I'm going to pick any relationship. So maybe I'll take, all right, my opposite is 3. My adjacent is 2. So in terms of opposite and adjacent, I'm talking about tangent. So this is going to say the tangent of angle A is equal to 3 over 2, opposite over adjacent. Now what I'm going to do to find the measure of angle A, remember, if we want to find the measure of an angle, we use our inverse trig function. So I'm going to say the inverse tangent of 3 over 2. And I'm going to figure out, using my calculator, the inverse tangent of 3 over 2 is equal to 56.3. So measure of angle A is 56.3 degrees. Let's erase some of this extra stuff. All right, I can mark in here that this is 56.3 degrees. Now, I would have gotten that answer whether I had done sine, cosine, or tangent from A or B. It does not matter. But that's the only answer you would get. And if you want to try that out, you can on your own. Maybe try doing the cosine of angle A, and it would be 2 over the square root of 13. And if you do inverse cosine of 2 over the square root of 13, you will get the exact same answer, okay? So there's not like one right way to go about doing it, but there is one right answer. So we only have one angle left, and that's this one, angle B. And because I know that 90 and 50, angle A and angle B are complementary, I can do 90 minus 56.3. I don't have to do another trig setup, and I get 33.7 degrees. Okay? All right. That's that. We have all three sides, all three angles. You did it. And again, they're saying rounded to the nearest 10. Let's try letter B. I'm going to do another Pythagorean theorem. 20 squared plus 21 squared equals c squared. 20 squared. And I'm going to do, I know you guys are confident with the Pythagorean theorem, so I'm just going to work that out. And I'm going to get that c is equal to 29. Okay, so we have three sides. Now let's take it from angle E again. Here, let's do a different trig function just for the fun of it. Let's go ahead and do sine. Okay, so the sine of angle E would be my opposite, which is 20, over my hypotenuse, which is 29. So they give me that the ratio, and this is what we did when we first started trig on lesson 9.4, the ratio from angle E of sine, we didn't do that till last lesson, but would be my opposite over my hypotenuse, and we would just stop there. And at the time, it didn't mean much. Here's why this is important, because now we can say the inverse sine of 20 over 29 is going to tell us the measure of angle E. So 20 over 29 is 43.6. So the measure of angle E is 43.6 degrees. So this angle in here is 43.6. And then to figure out what the other one must be, I would take that 90 minus that value, and measure of angle D is going to be 46.4 degrees. We have solved that right triangle. We filled in all of the missing angle values. And side values. All right, now in those ones, they get given us 2 of the side lengths. So remember up above, they said you can do this as long as you have 2 side lengths, or here's the other scenario we're going to do in letter C, 1 side length in the measure of, 1 acute angle. All right, so let's go ahead and use our sine, cosine, tangent. Let's call this x. So from angle 52 degrees, x would be my opposite, 8.5 is my adjacent, so that's tangent. So I can say the tangent of 52 degrees is equal to x over 8.5. If I multiply both sides by 8.5, I'm going to find 8.5 times the tangent of 52 is 10, those cancel, x equals 10.9. Okay, so I'm going to erase that little x and I'm going to mark in that this is 10.9. Let's write it with a different color. So 10.9. All right, now there's only 2 things left. There's the measure of angle y and there's the length of the hypotenuse. I can easily find the measure of angle y because I know that 90 minus 52, this angle is going to give me that this is 38 degrees. And then to find the length of xy, I can do the Pythagorean theorem. 8.5 squared plus 10.9 squared equals my hypotenuse squared. I'm going to work all that out. I will tell you what I get. You can try it on your own and see if you get the same thing. I got 13.8. So C is equal to 13.8. Now, if I was officially writing this out, like if we were in class, I would write the measure of angle x equals 52. The measure of angle y equals 38. The length of xy is 8.5, yz is 10.9, and yx or xy is 13.8. But with writing on the computer, it gets a little tricky. So, alrighty, so that we've solved those right triangles. Let's apply these to one last problem, and then I'll just have a few homeworks for you to give a go on for this last assignment. So here it says, you are designing a ramp where the horizontal distance is twice as long as the vertical rise. What will the ramp angle to the nearest 1/10 of a degree be? So hopefully, if nothing else, hopefully you can see how like everything we've known up till now, triangles extensively, they can, with trig, they can branch into like this endless, massive, applicable set of scenarios. Where you're finding unknowns, solving unknowns, using angle measures, working within these tons and tons and tons of applications with this stuff, which is why I really like trig and, trig functions in this chapter. Anyways, the horizontal distance is twice as long. So this is 2x, my vertical rise, twice as long as my vertical rise. They want to know what will the ramp angle to the nearest 1/10 be, and that's this angle right here. Let's call that angle A. All right, so from angle A, I have my opposite side is x, and I have my adjacent side that they're giving me information about. So that would be tangent. So I can say that the tangent of angle A is equal to opposite over adjacent. Now I know they're not giving us concrete numbers, but it doesn't matter because look, the x's cancel. So I'm left with the tangent of A equaling 1 over 2. All right, so now that that's the case, if we want to find the actual measure, we've learned in this lesson, we do the inverse of tangent. So the inverse tan of 1/2, if I calculate that out, is 26 point, rounding to the nearest 1/10, I would say the measure of angle A is going to be 26.6 degrees. So that would give me what my requirements are if I was building something to make sure that I'm meeting all specifications. All right, good work, guys. Feel free to ask questions at any point. A few problems for you to try, and you'll be set for the week. Good work. Bye-bye.